Okay, hello students. I would like to make a video on sine rule. So last time we had seen sine rule for ASA. So we did check for ASA or AAS. Today I would like to show what about if a triangle has ASS. So I have, and I call this sign ambiguous rule because there are a lot of cases, situation when one angle is given and two sides are given. So case one, so if a triangle is ABC, lowercase a stands for BC, lowercase b stands for AC. So all information is given, and so what is important main is the angle A. So what I did is I took angle A in all four cases. You will see angle A is 30 degrees. So I just take an actual example of 30 degrees. Then I also took the opposite side. So that's the opposite side A. And so we want to know what different values of A changes everything. Then B is given. So B is, I took it as 10. You can clearly see B is 10. In all cases, B is 10. Okay, so you have a 30 degrees. So and right now in case one, the case one is if the A is greater than or equal to B. That means, what does that mean? Do we have one triangle, or we don't have no triangle, or we have two triangles? So that's the question here is, how many triangles are possible? So just if A is greater than or equal to B, so B is 10, so this is lowercase b is given 10, and if the A, this is the A, if it is A, or if it is greater than A, you see this? So if you have, if A is 10, and this also is 10, you have an isosceles triangle. So if that is 30, this is 30, and we can easily use the sine rule. And you will get only one triangle. Or A could be 11. So if A is 11, this will be longer. So you still get another unique triangle. If A is 12, there will be another triangle. So always for every, if A is greater than equal to B, it means the side opposite to the angle given. So the side opposite to the given angle is greater than the other side, then we 100% get a unique triangle, just one triangle. So let's take the case 2, the second case. This case, what I do is, in this case I take, if it is, drop a perpendicular. So the question is, this will be 90 degrees. Okay, we want to know what's going on here. So if this is 10, that is 30, this angle is 60, and in 30, 60, 90 special triangle, if the hypotenuse is 10, this is 5, see? So you will be given here, A is 5, B is 10, and angle A is 30. Okay, so in this case, you get a one triangle. Now basically what I'm trying to say is this also is same as, now that's the opposite side. The opposite side is always the hypotenuse times the sine of the angle. So let me write this is the 10 times sine of 30 degrees. So sine 30 is half, and half of 10 is 5, so it makes sense. So what I'm trying to say is, if this lowercase a, so if A is the B, this is the B, right? So it is B and sine of the angle 30. See, and that 30 could be, it could be any angle maybe. Let's put it in this case. Since the vertex is A, I'm going to take, so if that's the case, 100%, you're going to get a fixed triangle. Makes sense? So that was case number 2. If A equals, if A is exactly equals B sine A, then you have a unique triangle. Case number 3. Case 3 is what if I take, let's see, if I have a side which is 7. So if you take a 7, so if A is 7, and you can clearly see this side A does not touch the base. So you never, no matter where you take, if I take this way, I can drop. So no matter where you go, it will never touch this. So you're not going to get a triangle. So a triangle cannot be formed if this A is lower. So here A is lower than the, remember this was B sine theta. So this one is smaller to this side. So it is A is, if it is A is less than, so A is less than B sine A. So in this case, there is no triangle. You say, hey, this one, there is no triangle. Then what about if, now, I will take 5 first, and 5 exactly touches. Can you see that? If it is 7, it is smaller than, sorry, I did make a mistake here. This should, it should be, let's say 3, let's take it as 3. I'm so sorry. So my point I'm making is this is 5, and this is 3. If it is 3, if 3 is less than, you can see 3 is less than 5, right? So if it is less than 5, you don't have a triangle. But what about let's take case here, A is 7. So if A is 7, then we're going to have, so this part is 5, right? This is 5. So this is 5. But if you take A is 7, so that means it will cross somewhere here, right? So it will go down. See, it is 7 this way. So that means you're going to get, so I can, so this A is greater than 5, and it was smaller than 10. So that means I can draw one of them this way. Maybe this one, 7. See? So if A is 7, this distance is smaller than that one, which is, this is again, I'll write it as 10 times sine of the angle, right? So this 7 is greater than that and less than 10. And you can see the case 4 is where B sine A is less than B. That means this A, if the opposite side is smaller than the other side, and also it has to be greater than, the orange color is greater than that 5, which is 10 sine A. I hope that helps. So this is one of the triangle gets formed. So let me write here. So this 7, okay, is less than 5 and is less than 10, right? But what is 5 means? 5 is, this is same as writing the B, that means B, because 10 is B, sine of the angle is less than the A, and that is less than B. See? So a lot of letters there, but the main thing is this the only triangle can be formed? 30, 10, and 7, but beside we can also, let me draw it right here. So one is 10, 30, this one 7. For the same 7, I could use this way also. So one is this side, and the other one is maybe a little smaller. So that's 7. So you have two triangles. One is this one, A, B, C, and the other one is, so you have an obtuse triangle and you have an acute triangle here. So this is another triangle and this one is B. So what I'm trying to show is this, there are ambiguous cases because there are two situations arises. If you are given an angle and the opposite side and the other side, if it is ASS, that's what I'm trying to say is you have two different triangles for the same situation. So in this example, angle A is 30 and the opposite side is 7 and the non-opposite side is B is 10. So such cases, B, here also B is 10, A is 7, angle A is 30. Then here also B is 10, this is A, and angle A is 30. So both cases the situation is the same, but you see the angles are different, these angles are different, and these distances become different. So each case we have to solve separately. So I hope these 4 cases are taken note. So the best way is you just check the opposite. So this is the main thing. If the opposite side of the angle is greater than or equal to the other side, one solution. If the opposite side is exactly B times the sine of the angle, then one triangle. But if it is less than B sine A, then you don't have no triangle. You can see the earlier example I showed. The last one is if the opposite side, so opposite side of the given angle, if it is smaller than the other side, and at the same time it is greater than B sine A, then you have two triangles this way. And that is called sine rule, sine ambiguous rule. Hope that helps. Thank you for watching.